Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in Pandas series, that is data transformation with Pandas. We will be watching the first part of this whole data transformation with Pandas in this particular video. So let's get started with the video. So this is going to be your first part of data transformation, as we are covering this whole topic into three parts. That is, this particular part we can cover up in this particular section, and then we will be dealing up with pivoting, unpivoting, reshaping and all, and then encoding, then feature engineering and handling outliers. So these are some of the transformation techniques which are getting applied on any of the data set in the Pandas. Now let me take you through the roadmap which we are following in the whole video series, or the learning roadmap. That is, first we have learned how to import data, then data exploration, then data cleaning, data selection and indexing, and now data transformation. Now you might confuse between data cleaning and data transformation. Just go and check out this data cleaning video, into which I have clearly covered up that what all cleaning techniques we are having. Now moving ahead with the data transformation. So in data transformation, today we will be dealing up with adding or dropping column, adding or dropping rows, inserting column at a specific location, inserting row at a specific location, and renaming column. So basically today we will be watching the detailed operations on column we can make into any data frame. So now starting with the first operation, these are the list. You can take a screenshot, into which I have covered up the general syntaxes for each of them, that how to add a new column, the general syntax for them, that then or to add a computed column to data frame. So all these things, you can refer this particular general syntax later when you will be dealing up with the real-time scenarios. So we will just move to our this one Jupyter notebook, where we will see our clear demonstration. So first we are adding a new column. So to add a new column, what we are doing over here, we are creating a data frame. After that, we are creating a new column with its value into the list. Now if we are declaring that inside this particular data frame which we have created above, we are declaring that C is the column name going to be the new column, and initially there are two columns that are A and B. So what it will do, as soon as we execute it, you can see that it has taken its place as after A, B, then it has taken the place as C, where the values are inserted. Now we are having second option of adding column, that is computed column. So there are multiple scenarios where what you do is you are calculating a new column, which is also called as calculated column, or the computed column, or the user defined column. So what you do, suppose you are having A, B and C. Basis of A, B and C, if you want to derive a new column, so this A might be, you can assume that this is the sales, okay, and now the sales percentage you want to identify for each of the row, definitely you will apply some formula. Or it also might be the scenario where you want to add A and B, and then whatever the result is, you are going to store it into the separate column, that is D. So in this particular scenario, that is only going to happen, that D is the summation of A and B. So this is how it is getting created, this column, the new column, that you just need to provide DFD and then DFA plus DFB. Now when you will retrieve your data frame, it will come up with the data frame in which D will be inserted as the new column along with its value. Now we are having another scenario, that add a constant value column. Suppose if you want to have a column into which a constant value it will be there. So in this particular scenario, I have just taken up a very basic example, into which there is a column, that is E, which is the newly created column, with having the value 10, which is the constant value. Here you can also provide some mathematical calculations and all, 10 into 2, anything you can do, and after each of the operation, this is also going to be your computed column only, but I have just differentiated it as the constant value column. So once we do it, we get this column with updated you may say column list, that is A, B, C, D and E with its value. Now we are having the dropping option. So these are the these are how we can create our column, or you may say add our column. Now after that we are having another scenario in which we will be covering up dropping the column. So we are having two scenarios inside that either you can drop single column or you can drop multiple column at a time. So if you want to drop single column, you will just provide the column name like this and then x is equals to 1. Why x is equals to 1? X is equals to 0, it means rows. X is equals to 1, it means it is going to be your column. So that's it. Now as soon as you execute it, you can see that E has been dropped, A, B, C, D is left behind. Now we are dropping multiple column at a time. So this is how we are going to be. We are just declaring whatever the column we need to drop into the list with x is equals to 1. So once we execute it, you can see that A and B are the only column which is left now. Then we are having insert column at a specific location. So what we are going to do is, so in this particular we were doing, we were inserting the column, but we were inserting at the last, right? What if the problem statement is something that this D should come inside between A and B? There should be some technique, right, to do it. So what we will do, we will insert the column on the basis of the index position. So what we have done over here, that we are creating a new column value, that is this. We are creating we are just taking up the values into the list. After that we are using dot insert method. Inside that we are providing the three parameters. First one, the index position, where you want to put that particular new column. Then the column name, which is your this particular column value. So column name you will provide, and the new column values, whatever values it is, so values you will provide. So as soon as you execute, you will see that C has been inserted between A and B, correct? So this is what it was required. Now we are moving towards our rows operation. Into our row, what we can do, we can append a row. That means we just want to add a row from the last. So what we can do, we can either append the row or we can concatenate the row. So why we are doing concat here? Because you can see that if we are going to append this particular row, what we are doing over here, we are creating a new data frame, then we are appending the data frame. That is, we are not appending the values over here, we are appending the data frame itself. We are creating a small data frame and data frame with the value, and that particular data frame we are just using dot append method, into which we are passing this parameter as new data, and then ignore index. This is new thing over here. So ignore index, what does it mean? That suppose if you are let me just first remove this particular one. Now if we will execute, what you will be able to see, you can see that A, C and B, correct? Now it has been inserted, this particular one has been inserted, these values into this particular data frame. But what you can see over here, that it is inserted into non-systematic order. That means index positions has not been conserved. So as soon as you now ignore index you are doing and then executing, just let me execute from here itself, from the beginning itself, so that the things will be fine. Why I am executing it from the beginning? Because we just want to retrieve our original you may say the index values. So since we have ignored the index, so it has been taken up its own value and it is giving. Now you can see that the index, ignored index, as soon as we did, you can see that index position has been now systemized. That means 0, 1, 2, 3, 4, A, C and B, correct? After that we are having concatenate row. So what we are going to do is, we are going to do the same operation whatever we were doing in the append, but with the different method, that is dot concatenate. Into it, what we are going to do, we are providing two data frames, that is the original data frame, into which we are going to append the another data frame, that is df2. This is the new data frame with axis equals to 0. Why axis equals to 0? Because we are having row operation over here. Now reset index drop equals to true, we are providing. Why? Just to preserve our index position to we execute it. You can see that index position has been conserved and A and C and B column has been created. Now we are having drop row by index. So if suppose somebody tells you to drop row on some particular index, suppose it is residing, so here we are having six, you may say 6 indexes, 7 indexes, right, including 0. So if we want to remove some of the index from there, definitely you should be having some technique. Suppose you want to remove this index position 1, if you want to remove index position 2, you should be having some technique to do it. So here what we are going to do, df.drop and drop rows with indexes 0 and 2. So 0 and 2 it will be dropped. You can see that it has been dropped, and it is what it is giving you as soon as you execute it after dropping. Okay. So now moving ahead with the resetting index of rows, of course the 1, 3 and 4 has been indexed over here. So again we will reset the index with drop equals to true. Then you can see that 0, 1 and 2 has been created as the index now. Correct. Now conditional row removal, if suppose you want to remove the condition row on the basis of some particular condition, which we have already covered up into the filter section, where we saw that how we can filter out some particular row from a data frame. Same we are doing over here, that we are just applying some condition basis of which whatever row it will satisfied by this particular condition, those will be here, and rest of the things will be not here. So it depends upon your operator. Here we have used not equals to operator, which means that the row which is not equals to 4 in the column A, it will be removed, other things will be there. So you can see over here that inside A there is 2 and 5, there is no 4. It was 4 earlier, correct? So it has been removed, and you can see 0 and 2 has been there. So if you want to again reset the index, you need to run this particular query. After that we are having insert row at a specific location. So we saw how to insert column at a specific location. The example with C has been placed between A and B. Similarly, this time we are going to cover up how to insert row on some particular location. So here we are going to insert row on the location 1, correct? So 2 and 7 it is there, right? 2 and 5 it is there. Now what we are going to do, we are going to insert this 7 and 8, this particular value, which is our row. So when we are inserting, you can see that 7 and 8 has been inserted. Fine, 7 and 8 has been inserted on the this particular index position, correct? So this is how it is right now getting executed. Now moving ahead with the rename column greater than using the rename column using the rename method. So basically, if you want to rename your column, you are having two options to rename. There are two ways with which you can rename your column. Either you can rename it with the method rename, or you can directly assign some new name to that particular column. It will be directly renamed. So how it can be done? So let's see. So here you can see that we have used dot rename method. In dot rename method, we are having this particular new column. In this new column, this is the previous column and this is the new column it is going to be. If you want to have multiple, you will just apply comma and you will put your again old column name, then new column name, correct? This is how you are going to apply. Now what you will do, dot rename, and the parameters you will pass columns equals to new column name and in place equals to true. Why in place equals to true? You need to change the original data frame itself, whatever we are renaming it right now, that means A should be originally be replaced with F. So once we execute it, you can see that A has been replaced with F. Now we are having another way with which we can rename our column, that is direct assignment. Suppose you are having this particular one, F, C and B. Now these three columns we need to rename. We will directly do df.columns. We will tell to the data frame or the pandas that we are going to use columns as G, H and I into the data frame df. That's it. Once you execute it, it will be replaced with FCB, will be replaced with G, H and I. So these were all the techniques into the data transformations into the pandas. This was the first part of transformation video on pandas. Stay tuned to the channel for the another parts as well. I will be explaining each of the concept. Thank you so much guys for watching out the video. If any confusion, let me know into the comment section. See you in the next one with some other topic. Thanks again.